In this video, we will go over how to transform your cell count data in order to make a bar graph in RStudio. Starting in Excel, we have our cell counting spreadsheet. Quickly, let's go over how to set up your Excel spreadsheet for cell counting. First, you want to start with the slide and what slice is being counted. We have the slide in the first column and then slice in the second. R indicates the right hemisphere and L indicates the left. Having the slices numbered helps indicate whether we are closer to the dorsal versus the ventral part of the brain. As the higher the slice number, the more dorsal we will get. The next two columns contain the cell counts for the two areas of the hippocampus we looked at in our study, and then the sum of the two areas in the last column. Setting up your cell counting in an Excel spreadsheet like this ensures the data is organized and easy to read. Once multiple people have counted the cells, we can combine the counting data into an Excel spreadsheet like this one, with the ID, treatment group, and the results from each counter. The next step is to import this data into R so that we can work with it. To do this, save the Excel file as an XLSX file to your computer, then click the Import Dataset button on R and browse to select the file from your computer. Once selected, you can preview the data and view the code below. Using the code row means, we can take the mean of the columns count A and count HO from the dataset book 2. We'll call this variable mean. We can now add this new data into our original book 2 data frame. To do this, we can use the code book2 $mean, and this will be what the column is called, then the assignment operator, and the variable mean, which is what our mean values are coded under. So now the result is a completely new column in our data frame with the average between the two counters. The next step we can do is separate this large data set into smaller data frames that have each treatment group. To do this, we will call each new data frame just what its treatment group is, and then we use the code book2, which is the data frame we're going to take the data from, and inside the brackets include the rows that you want to include in each new data frame. So for control, the data is in rows 1 to 9. So inside the brackets, you will do 1:9. This can be repeated for each treatment group to get 4 different data frames containing the data specific to each treatment group. This will make the data a little bit easier to work with in these next steps. Now that we have all the treatment groups separated into different data frames, we can take the overall average cell count for each treatment group, which we can then use to create a bar graph. For this code, we will use the name as what treatment group we are doing, and then mean, then do the assignment operator, mean, and in brackets, you do what data frame you want. So in our first case, it's the high data frame for high dose, $mean, because we want to take the average of the mean column. This can then be repeated for each treatment group. So now we have the mean cell counts for each treatment group as variables, and we can use these later on. In a similar way, we can calculate the standard error of the mean using the standard error formula. And again, this can be repeated for all 4 treatment groups. Now that we have the mean and the standard error of the mean calculated, we have all the components needed to create our bar graph. Let's combine them together into a single data frame for easier use. The first column will be the groups. Taking a look at this code, the part C bracket control huge, high, and low will create a list with our group names. We use the rep function to repeat each group name multiple times, and the each equals length brackets control mean part tells R to repeat each group name as many times as there are elements in the control mean vector. Because there's only one element in that vector, each group is just repeated one time in the column we have just created. And now if we input groups into R, we can see that a vector has been created with each of the 4 group names. Next column we'll create is the values column, and in this column we'll assign the means for each treatment group to the value column. And now you can see if we run the values column in R, the actual values for each mean of the treatment groups will be printed out. Finally, the last column is the standard error of the mean column, and for this it's very similar to how we inputted the values, except you're going to use the variables for the standard error of the mean for each treatment group. And again, we can put in SEM into R and see the standard error of the mean values printed out. Now that we've assigned these variables, we can create a new data frame with all the variables included from the code below. And finally, we can view our new data frame and see the result is a column with each group name, the values for the mean, and then the standard error of the mean. Finally, we can start plotting our bar graph. The first step is to load the ggplot library, so make sure you have this installed. I have copy-pasted the code to create a simple bar graph below, and we can quickly run through how to read this code. The first step is to load the ggplot2 library, so make sure you have this installed. Next, we are calling this graph mean cell count plot, and ensuring that you label the graph makes it easier to recall later on when you need to see the graph again. So that will go in front of the assignment operator. Next to the code is ggplot in brackets data, which indicates what data frame we're going to use for the graph. Then the AES in brackets x equals group, y equals value. This assigns the x and y values to the graph. The next part of the code is the geom_bar, and then in brackets stat equals identity, comma, fill equals sky blue. This is adding the bar plot layer and then filling the bars in sky blue. Then the geom_error bar adds the error bars to the plot, and the AES function specifies that the lower end of the error bar is value minus SEM, and the upper end is value plus SEM. And then the width equals 0.2 just sets the width of the error bars. And then the next part of the code, labs bracket title. This adds labels to the plot. The title argument sets the title of the plot, x equals sets the x-axis label, and y equals sets the y-axis label. And the theme minimal just applies a minimal theme to the plot. Most of the code when you're creating a bar graph or any other graph is a little bit more customizable. For example, if you want to change the color of the graph, you can do that, and then changing the error bars and adding on different features of the graph is all completely doable by slightly altering the code. And now we can print our graph and view it on the right-hand side. So as you can see, we've created our bar graph with the mean cell counts on the y-axis and the treatment groups on the x-axis, and the error bars we have showing the standard error of the mean. We hope this video has provided sufficient demonstration to help you learn how to arrange your cell count data in Excel and how to import it into RStudio to create a simple bar graph.